Antibiotics are like tiny warriors that fight off bacterial infections, acting as our body's defense system against harmful invaders. They work by targeting specific parts of bacteria, like the cell walls or the machinery they use to make proteins, effectively disrupting their life processes. This can either kill the bacteria outright or stop them from growing and multiplying, preventing the infection from spreading further. Imagine a microscopic battle taking place inside your body, with antibiotics acting as the cavalry charging in to save the day. On one side, you have harmful bacteria trying to make you sick, causing symptoms and potentially severe health issues. On the other side, you have antibiotics sent in to fight the infection and restore your health. Antibiotics have been incredibly successful in treating bacterial infections, saving countless lives over the years and revolutionizing modern medicine. However, their overuse and misuse have led to a growing problem: antibiotic resistance, making it harder to treat infections that were once easily curable. It's crucial to use antibiotics responsibly, only when prescribed by a healthcare professional, to ensure they remain effective for future generations. Just like any living organism, bacteria can change and evolve over time. These tiny organisms are constantly adapting to their environment in fascinating ways. These changes happen through mutations in their genes, which are like blueprints that determine their traits. Mutations can occur naturally or be induced by external factors like radiation or chemicals. Some of these mutations can make bacteria resistant to antibiotics, a phenomenon that poses a significant challenge in modern medicine. Think of it like this. Imagine a group of bacteria, each with a slightly different shield. These shields represent their varying levels of resistance. When antibiotics arrive, they can only penetrate certain types of shields. The effectiveness of the antibiotic depends on its ability to breach these defenses. The bacteria with the right shield survive, while the others are killed off. This selective process ensures that only the strongest, most resistant bacteria continue to live. These resistant bacteria can then multiply and pass on their resistance genes to their offspring, spreading the resistance trait through the population, creating a new generation of bacteria that are no longer affected by the antibiotic. This cycle of mutation and selection is a natural phenomenon that highlights the adaptability of life. When antibiotics are used, they create a selective pressure on bacterial populations. This means that resistant bacteria have a survival advantage over susceptible bacteria. Imagine a field of flowers, some red and some white. If you were to spray the field with a herbicide that only killed red flowers, the white flowers would survive and reproduce, eventually dominating the field. The same thing happens with bacteria. When antibiotics are used, they kill off the susceptible bacteria, leaving behind the resistant ones. These resistant bacteria can then multiply and spread, making infections harder to treat. As antibiotic resistance continues to spread, it is becoming a global crisis that affects everyone. We are seeing the emergence of superbugs, bacteria that are resistant to multiple antibiotics, making them incredibly hard to combat. These superbugs pose a serious threat to public health, as they can spread rapidly and cause severe infections. These infections are difficult or even impossible to treat with our current arsenal of antibiotics. Imagine a world where a simple cut or scratch could lead to a life-threatening infection, a scenario that is becoming more likely. This is the reality we face if we don't address the problem of antibiotic resistance with urgency and determination. To prevent this from happening, we need to use antibiotics responsibly, develop new treatments, and educate the public about the dangers of misuse. Additionally, we must support research into alternative therapies and innovative solutions to combat these resilient bacteria. The future of healthcare depends on our collective efforts to tackle this growing threat head-on and ensure a safer world for everyone.